Hi friends, today we do establish some relation between hardness and coefficient of friction. Hardness and coefficient of friction, what is relation? We try to differentiate them. So friend, this is a workpiece, first workpiece and second workpiece, and this is sheared out. Normal force N is applied and this is shear force. Friends, after this conjunction, this portion is elastic region and this is a plastically micro-weld. So friends, according to the addition force theory, F is the force required to shear the junction. F is the force required to shear this junction. Okay, thus the friction force. The coefficient of friction mu at the interface is defined as mu equals to F divided by N. Shear force divided by normal force you see in this picture. Now friends, you know shear stress tau equals to F divided by AR. AR equals to real area of contact. Real area of contact denoted by AR. So if you find out F, then this multiply tau multiply AR, and also you know normal stress sigma equals to normal force divided by AR. So if you find out N normal force, then sigma multiply AR. So friends, put in this equation F equals to, you put tau multiply AR divided by N value, this sigma multiply AR, and after you got this shear stress divided by normal stress. So mu equals to tau divided by sigma. Friends, for plastic deformation asperity, you see here this is a plastic deformation, micro weld. More force is turned this sheet into micro weld. So for plastic deformation asperity, normal force sigma is equivalent to the hardness. Sigma is equivalent to the hardness. Okay, so now in this equation we put mu equals to what? Tau divided by sigma, and sigma equals to the hardness, so tau divided by hardness. So mu equals to friction coefficient equals to shear stress divided by hardness. This is your main relation between coefficient of friction and hardness. So coefficient of friction mu equals to tau divided by hardness. Friend, this equation indicates that if coefficient of friction can be reduced either by decreasing the shear stress, it will be decreased if you want to decrease shear stress, such as by placing a thin film of low shear strength in the interface. If you want to decrease this shear stress, then you want to allow a thin film of low shear strength in the interface of 1 and 2nd workpiece. Okay, or you also be decrease this mu by increasing the hardness of the material involved. In mathematically we solve here. If you want to decrease mu value, then you want to decrease shear stress. And what is means, if you want to decrease this shear stress, then you also apply a thin film of low shear strength in the interface. Or if you want to decrease this, then you increase this value. If you increase this hardness, then this value decreases, because mu inversely proportional to hardness. Mu inversely proportional to hardness. So if this increase, then this decrease. So this is all about you. Coefficient of friction equals to shear stress divided by hardness. So thank you. You enjoy this lecture.